might take a minute and just kind of show you where some of these formulas come from. I've just kind of magically been giving you formulas and not really justifying them. So you don't necessarily have to write this down. I'm only going to show you a couple here today. So double angles means when you have 2 times an angle. And we can find this just by using a sum formula. So 2 times an angle, that's the same as a plus a. And we have a cosine sum formula. That's cosine of the first, cosine of the second, minus sine of the first, sine of the second, right? And I will put all of these final formulas up here in one slide in just a second. So, what is cosine times cosine?
Cosine squared.
So that's cosine squared a minus sine squared a. So that is the first double angle formula for cosine. We actually are going to get 3 different options for the cosine double angle because when we look at this, we know that if I take cosine squared, what could you replace cosine squared with?
1 minus secant squared.
1 minus sine squared. So if I took that formula we just found and I replaced the cosine squared with 1 minus sine squared, then if you combine my terms, negative sine squared and negative sine squared is negative 2 sine squared a. So that's another variation we could have. Or I could replace sine squared. What is sine squared equal to?
1 minus cosine squared.
And so if you distribute that negative, cosine squared plus cosine squared is 2 cosine squared minus 1. So there's 3 different options. The sine double angle formula is found by the same way. Use the sine sum formula and expand that. Same thing with tangent. So I am going to give, these are all of the double angle identities. Cosine has 3 options because of what I just showed you. Sine and tangent only have 1. Just like the others, these are all on the formula sheet, so you don't have to memorize anything. You just have to be able to use them. So, this one says, I'm going to give you that sine of theta is equal to 8 over 17, and cosine theta is less than 0. I want to find sine, cosine, and tangent of 2 theta. When you get to the homework, I just want to clarify, like the first questions, if you read your directions, it's going to say find sine, cosine, and tangent of the given angle, and then when you go to the problem, it'll say 2 theta, and then this. If you read the directions, it's saying find sine, cosine, and tangent of 2 theta. So, just clarification there when you get to the homework. All right, so let's start. When I need sine 2 theta, there is only one option for that formula. Sine 2 theta is, if you look at your formula, 2 sine theta cosine theta. All right, there's a problem. I currently know sine is 8 over 17, but do I have cosine? No, so we have to find cosine. Let's just go back. At the beginning of the year, we did triangles a lot, right? Sine is positive, so we know it's either quadrant 1 or 2. If cosine is negative, what quadrant are you in? Quadrant 2. Think SOHCAHTOA. Sine is opposite over hypotenuse. How would you find this other side?
Take a variable for the other side, say x squared plus a squared equals 17 squared.
Square root. With that, it's plus or minus. How do you know if it's positive or negative?
By quadrant.
Yep, in quadrant 2, your x is negative. So square root of 2, 25 is 15. So that's negative 15. So now, can you tell me what cosine is?
Negative 15 over 17.
we multiply these. 2 times 8 over 15, or 8 over 17 times negative 15 over 17. So we get negative 240 over 289. Not pretty, but it works. Alright, cosine 2 theta. You have 3 different formulas. You could pick any of those 3 formulas to use. We've already found, we have both sine and cosine, so we have the information for all of them. The original problem, you were given the value of sine, so if you wanted to pick that formula, you could. It doesn't matter at all. So which one do you want to use?
Cosine squared theta minus sine squared theta.
Okay. So cosine of theta, my theta triangle adjacent over hypotenuse, so that's negative 15 over 17 squared, minus sine of theta was 8 over 17 squared. So then we just calculate. So cosine 2 theta is 161 over 280. Alright, how do I get tangent?
You take tangent theta over 1 minus tangent squared theta.
Okay, so from my triangle, tangent opposite over adjacent is negative 8 over 15. It's kind of ugly, but we can use our calculator and figure this out. And it gives me negative 240 over 161. Can you think of any other way we could have found tangent to theta? We know tangent is sine over cosine. So tangent to theta would be the same as sine 2 theta over cosine 2 theta, right? If you've already found sine and cosine, you're welcome to use those. We found our sine to be negative 240 over 289. Cosine was 161 over 289. So you can put it in the calculator or flip and multiply. And we get the same answer. So we have a tangent double angle formula, but if you've already found sine and cosine, you could just divide those to get tangent. All right. Is that one okay? Let's try one more and make sure we've got that. What do you want to do first?
So the cosine theta equals cosine squared theta minus sine squared theta.
Okay.
And then set up the triangle from the back side.
Okay. And we could, I just want to talk about if I use one of the other formulas. I mean, we're going to need to find the sine anyway, so it's not a big deal. But we have cosine theta. You could choose to just do the 2 cosine squared theta minus 1 formula. Just to use a different formula than we did last time. We'll get the same answer. Cosine theta was 3/5 squared minus 1. So, what do you get? Cosine 2 theta is negative 7 over 25. For sine 2 theta, we don't have formula options. So we have to use the cosine, 2 sine A cosine A. So we have to have both sine and cosine to use that. So we need a triangle. Cosine is positive, so that's either 1 or 4. Sine is negative, so that means it's quadrant
4.
So this is for triangle theta. Cosine is adjacent over hypotenuse. So Pythagorean theorem. Since it's, and
Could it be 4?
it would be a negative since you're in the 4th quadrant.
Negative 4.
So sine is negative 4 over 5. Cosine, adjacent over hypotenuse, is 3/5. So I get negative 24 over 25. What would be the easiest way to find tangent now?
Do the sine over cosine.
Yeah. I would sine 2 theta over cosine 2 theta would definitely be faster. So sine is negative 24 over 25 divided by negative 7 over 25. Flip and multiply. You get 24 over 7. Is that one okay? Let's go to this example. So I'm asking for all the trig functions of theta this time. Okay, that's different than the others. What I have is cosine 2 theta. Okay, I can't just set up a triangle to find everything because this is for 2 theta, not theta. But think about your formulas. The cosine 2 theta formula. We have 3 different options, right? I don't want to use the first one because it has sine and cosine in it, but I could use either of the other 2. So let's say I said, okay, I'm going to go with cosine 2 theta equals 2 cosine squared theta minus 1. Let's plug in what we know. Cosine 2 theta is negative 12 over 13. So then if we solve this, we add our 1 over. then what would we do? Divide by 2. And then we have to square root. When you square root, you have plus and minus. We have to figure out if it's positive or negative. So we look here. It tells us that theta is between 180 and 270. That's quadrant 3. And quadrant 3 is cosine positive or negative? Negative. Square root of 1 is 1. We don't know the square root of 26. So if you multiply, you get negative radical 26 over 26. Okay, I have 5 functions to go. I asked for all of them. But,
Cosine's opposite of secant.
okay, so we automatically know secant. And if I just flip this before I move the radical, you get negative radical 26 over 1, so negative.
Negative radical 26.
So we could repeat this process to get sine. We could do the cosine 2 theta equals 1 minus 2 sine squared theta. Or we could just set up a triangle now. So we want all the trig functions for theta, so we need the triangle for theta. We already said it's in quadrant 3. Cosine is adjacent over hypotenuse, so this would have to be a -1. My hypotenuse is always positive, so that's a positive radical 26. And then you could do Pythagorean theorem. 1 plus b squared equals 26. So b squared equals 25. Would it be a positive or a negative? Negative, because you went down. So then sine, opposite over hypotenuse, -5 over radical 26, or -5 radical 26 over 26. Cosecant, reciprocal of sine, so if I just flip that, negative radical 26 over 5. Tangent, opposite over adjacent, so -5 over -1 is +5. Cotangent, if I flip that, we get 1/5. So really, once you have one function, the easiest option is just to set up a triangle to get the rest. Is that okay? All right. Let's do. What would we do first?
Set up cosine square 2 theta is equal to 2 cosine squared theta. And then plug the 2 over 3 in there, the cosine 2 theta. And you'd add the 1 over. Then you divide by 2. And then square root.
Square root means plus or minus, so we have to figure out what quadrant we're in to decide.
We're in quadrant 2.
Theta is between 90 and 180, so that's quadrant 2. In quadrant 2 is cosine positive or negative?
Negative.
So we have negative radical 5 over radical 6, or negative radical 30 over 6. Okay. I only asked for sine and cosine this time. So I could get sine by using the other double angle formula, or I could do a triangle. Both options are going to work. Which one do you want me to do?
Triangle.
Triangle. So we have cosine theta, so we can set up our theta triangle. Cosine is adjacent over hypotenuse, so I'm going to use before I move the radical. So my adjacent is negative radical 5, my hypotenuse is positive radical 6. Remember, the hypotenuse is always positive. So Pythagorean theorem, a squared plus b squared equals c squared.
It's gonna be what?
And plus or minus, but since we're going up, that's a positive one. So then what is sine of theta?
1 over the square root of 6, but then you have to times it by 6, so the square root of 6 over 6.
Are these okay? Let's try a proof. Which side would you box in?
The right side.
How would we simplify cosine to the fourth minus sine to the fourth?
It's the same as sine squared plus cosine squared equals 1.
Well, we'd have to factor it first, the difference of squares. So cosine to the fourth, if you have 4 cosines, half of them would be cosine squared. Difference of squares, one gets plus and one gets minus. Sine to the fourth would be sine squared. What is cosine squared plus sine squared? What is cosine squared minus sine squared? It's all for me. All for me.
Well, you just give up.
I do. Special treatment. Alright. So what's that equal to?
Cosine 2a.
Yeah, that's the double angle formula for cosine. And 1 times cosine 2 beta is cosine 2 beta. Alright. Do we need another proof, or you think that's okay?
I'm good. I don't know if I am, but
Let's try. Let's see if we can do this. Simplify each of these things. So 1 minus 2 sine squared 22.5 degrees. What formula does that look like? 1 minus 2 sine squared.
a cosine 2.
That's a cosine 2a formula. My a is the angle, so it's 2 times 22.5. What's 2 times 22.5?
45.
And what is the cosine of 45?
Square root of 2. That looks like tangent to A.
Mm-hmm. Look at your identities. Your tangent 2A formula is 2 tangent A over 1 minus tangent squared A. So that's exactly what this is. What's my A?
22.5 degrees. So then tangent of 45 degrees again.
And what is the tangent of 45?
1. That's a cosine, right?
Cosine squared minus sine squared. That's a cosine 2A formula. My A
Is the 5 pi over 6.
So 2 times 5 pi over 6, that gives us 5 pi over 3. What quadrant is 5 pi over 3 in?
In quadrant 4.
Reference angle is pi over 3, or you could think 60 degrees. In quadrant 4, cosine is positive. Cosine of 60,
Square root of 1 over 2 or just 1 half.
one last problem.
That's the sine 2A.
Okay, it's kind of like the sine 2A formula, isn't it?
Instead of the 2, it's a 4.
Right.
So, would you have to factor that out?
Sine 2A is 2 sine A cosine A. So this 4, you could think that's the same thing as 2 times 2. So this is 2 times sine of 2A formula. Two times pi over 12 is pi over 6. Same thing as 30 degrees. What is the sine of pi over 6? It's the sine of 30 degrees.
1 over 2.
So if you have an extra coefficient in front, you just carry it on through. Any questions? So let's try some when you've got time to ask some questions. So there's only 8 problems.